Or just look at the graph?
It just looks like it's going up.
Good. So what's the relationship between the two?
The higher the boiling point, the more the carbon.
Yes. If there's more carbons, the boiling point is higher. So it's a direct relationship. As the number of carbons increases, the boiling point increases. And I drew that little column thing. We'll talk about that down the road. But that's a good way to a way to separate crude oil. It's called fracking. Fracking on the brain. Everyone talks about fracking. It's called cracking. That's what it's called. Fracking. No, I still hear a decent amount of news and such. But anyways,
Don't start a political debate.
so no, we're not talking about that. Yeah, it's a direct relationship. Keep that in mind. Okay, now we used table P yesterday to learn how to name and draw a little bit. Let's try one right now. Can you guys give me the formula for octane? Oops. Formula for octane. C8. Hold it. You're doing good, but to yourself. C8, yes, but now do the rest on your own. Don't say it out loud. C8. Don't say it. Got it. C8H. Go ahead, Ryan. 18. Good. So that's octane. It fits the general formula for an alkane. Now, I would expect you, if I wrote this on the board, if you came in here, sometimes I have the warm-up problem. If this was sitting on the board, C8H18, and I said to you guys, true or false, that is saturated, I would expect you to be able to figure that out. And some of you might be like, what? What are you talking about? Alkanes are called saturated hydrocarbons. Why? Because they're single bonded. Why? What does that mean? It has all the hydrogens it possibly can hold. That's going to make way more sense when you do the lab back there. If you turn around, you can see all those molecules out. When you do the lab, you're going to see that some of them have single bonds, some have double. There's one with triple. And the one with a double or triple bond doesn't have as many hydrogens. It just can't because of the double bond. So we'll get to that. But this is an alkane. So here's the process. If I wrote this, and I didn't give you the name, and I wanted you to tell me, is it saturated? And you know alkanes are saturated, you would take this and match it up on table Q to one of the general formulas. You would see it only fits the alkanes, so you would say, yes, it is saturated, because it's an alkane. So I would expect you to be able to do that right now. Hopefully that's a good expectation. All right. So yesterday we talked about carbons in a straight line. What do we call that?
Straight chain.
Straight chain. Good. Question? You can. Now we're going to talk about branched alkanes. Branched alkanes. And when I say branch, what do you guys think of?
Trees.
Trees. Yeah, of course. So you have the trunk, and then the branches come off of the trunk. They branch off of the trunk, right? That's where we use that word branch for other meanings instead of trees. But branch means coming off of something, right? It's a piece of something. So just watch for a second. Don't write this. If I had a straight chain carbon, straight chain of carbons, this here is kind of like the trunk of the hydrocarbon. By the way, hydrocarbon is what? Hydrocarbon. What is it? An organic molecule that contains only carbons and hydrogen, right? Hydrocarbon, hydrogen, carbon, right? So this is a straight chain hydrocarbon, but if I was to put carbons off of this one, if I was to put carbons off of this, also off of that straight chain, those are called branches. These are the branches. So this is kind of what a branch alkane looks like. Yesterday we did just straight chain with hydrogens. Now we're going to be hooking carbons off of the main chain. Sometimes this is called main chain, parent chain, or carbon backbone. Why would a backbone make sense?
Because the main structure is stronger.
Well, sort of. Think about humans.
The middle of
Depends.
What branches off of?
Nerves.
Right. Ribs, arms, legs, everything branches off our vertebrae, our backbone, right? So our backbone is right in the middle, then things branch off it. That's where that came from. So here's the backbone, things are branching off it. So this is what we're going to be learning today. So I want to explain it first so you kind of know where we're headed. But yesterday we named inside the box. Now we're going to have to start naming these things that are hanging off, called branches. So let's write a few things down before we can do that. Let me give you the information first, then you're going to use that to do some examples. So here we go. Branched alkanes. What the heck is it? It's a straight chain alkane that has substituents branched off of it. It's kind of a plain way to say it. Straight chain alkane that has substituents branched off of it. And a substituent, another name for that, is called an alkyl group. Alkyl group. And the word alkyl group and substituent mean literally the same thing. They mean the same thing. Alright, so substituents and alkyl groups. You have no idea what they mean yet, but I'll explain. Substituent, the literal meaning of it is usually used, it's something that's part of something larger. So I guess, I can't think of a good one for you here, but our school district is kind of the big picture, right? BKW Central Schools. Well, we have the elementary, which is one substituent, middle, high school, the other substituent. So together we make up the entire school district. So substituent is a piece of something bigger. That's what substituent means. Alright? So what I just drew, those carbons I circled, those are substituents. They're smaller pieces attached to something bigger. Alright? So, let's first start with those substituents. There's three types of substituents. Three substituents. Three substituents. And you're going to be really confused until we get to examples, but I promise you, you will get it. Every year there's confusion at first, then everybody gets it every year, every time, I promise. Here we go. The first substituent is called a methyl group. A methyl group. And the methyl group has the formula CH3. Or, if we want to draw the bonds, it looks like that. So a CH3 is called a methyl group. So if I was to take this apart, this thing in my hand right here, this is a methyl group. It has one carbon, the black one is carbon, with 3 yellow. That's a methyl group. That's a methyl group. So this here, this bond, notice how this bond is just kind of hanging out there. There's nothing there. That's because you're going to take it and you're going to stick it onto something that's part of a big chain. So this would be something hanging off a big chain. So that's one. The other one is called ethyl group. Guess how many carbons ethyl has? 2. So it's CH2, CH3. Or, if we draw the bonds, how many lines per carbon? How many lines per carbon? 4. 4 bonds. Why?
Carbon has to form 4 bonds.
Yeah, but why? It has 4
Valence electrons.
valence electrons, right. There's an ethyl group. Here's an ethyl group right here. CH2, CH3. Okay? Looks like a dog missing its head. Okay? So, the headless dog.
Or missing his
really
tail.
long tail.
No, the head, the neck, in my...
Yeah, I kind of like the tail better.
The tail's got to be shorter.
Why
No,
would it have a massive
long neck
at the end of its tail?
with a head and a tiny tail.
With a massive long
Dad, can we
tail.
get-
So, oh, you want to get back to learning
Yeah,
chemistry?
I think
Honestly, I'd rather talk about that than headless dogs.
Oh, really? I think the idea of a headless dog is kind of cool.
What's wrong with you?
I think Mr.
I'm
McCoy
just
likes
joking.
this
Let's
theory.
go. Now, this is, I just found that
Headless dog,
very funny.
children on leashes.
All right. Now, this is a CH2, CH3. This is an ethyl group. This doesn't have anything bonded to it because you would stick that into a chain. This is another substituent. Guess what's next? Use table P. Propyl. Propyl group. Propyl. Put a little star. That's really, really rare. You're not going to see that on the regions. You might not even see ethyl, but I'll teach you anyway. So CH2, CH2, CH3. That's a propyl group, and that would look like that. So you would have 3 carbons connected. The first one would only have two bonds actually formed, and then 1 bond ready to go. So that would be your propyl. That would be hanging off of a chain. So this would also be a
Are you
substituent.
going to draw that in the other corner?
I am not. So I'm going to be lazy.
the like condensed things? Is that what you're doing?
These are condensed. These are structural. Yep.
Okay.
Yep. Yeah, Dan.
So,
Need a pen?
I don't know, because it's working over here, but as soon as I try to draw the next H, it doesn't work.
Sometimes that happens.
It's just in that one spot.
Yep,
I don't know what's going on.
That's okay.
I've had that happen
Dan?
before. That's why I had to
You want
stop
my pen?
using
No, I'll
pens.
just skip that.
He'll figure it out. All right. So here's the substituents. Let me explain how we use them.
Pens.
All right. Write this down, please.
She
Good.
didn't finish.
She didn't finish.
It's okay.
Okay. 2-methylbutane. Write that down. And then next to it or under it somewhere, but leave some space if you're going to write under it because we got to draw structure. That's the name we're going to draw it.
No.
We're going to draw it.
You were
Now. Another example. Don't draw that.
If we were to draw that, where are we drawing?
Well, that's up to you really, but leave space underneath here to draw a structure, and then that structure we're going to name. So as long as you have enough space in your notes. This, I'm also going to do the condensed next to it so you can see the difference. Those two structures are identical. The one on the right is condensed, the one on the left is just called structural. So those, I'm just for your information so you can see how they look different on the board or on paper. And I'm going to give you a little hint here that's going to make your day. You don't have to actually draw all the H's in, but you do have to draw the bonds. So if you were to draw this like this, it's 100% wrong. You will get 0 credit on the Regents or on a test or quiz for me. So you cannot do that. You have to show the lines. You have to show 4 lines per carbon. Yes?
Where it's like the C, the other carbon comes off the down, when it's got like an H on the left going over, would that also be shared by the one?
Nope, it's two separate. Two separate.
I feel like then they would collide sometimes. Pretty close.
They're actually close. So if I took this off here,
Yeah.
they are kind of close.
Okay, okay.
Yeah. Okay. All right. Oops. What? Hold on. Dan got me all discombobulated here.
My bad.
I love that word.
Okay. All right. Now, I need you to really clear your mind and pay attention here. Okay? Because the first time you learn this is going to make or break you. All right? So here we go. Pay attention. 2-methylbutane. That's the name. We're going to draw it. You're going to draw one of those structures for this. Here's how you do it. You work backwards. You draw this first. Draw butane. So, I'll do it with you. How many carbons in butane? 4. So we go 1, 2, 3, 4. Butane means single bonds. It's an alkane. So we have single bonds. So that's all we have to do for that. Don't forget, all your bonds coming off of the carbon. So that's butane. I'll go slow. So that's butane. Now, 2-methyl. Well, let's do the 2 last. Next, methyl. Look at your notes. What does a methyl group look like?
3.
Right, so we need a carbon with 3 H's. You with me?
Yes.
A carbon with 3 H's. That's what a methyl group is. Guess what the 2 tells us?
There's 2.
2 of them.
Close. It tells you where the C with 3 H's is attached. The second carbon branched off of it has a C with 3 H's.
Doesn't matter top or bottom.
You can go up or down, doesn't matter. This here is our methyl group. This here is our butane. I use circle and a square or a box there just to keep it separate. So the name of this, the drawing, is 2-methylbutane. 2-methylbutane. Why 2? Because you number the carbons. 1, 2, 3, 4. But here's the part you need to know right from the start. You can number this any direction you want. If I put this carbon here, it's exactly the same thing. Why? Because that's 1, 2, 3, 4. That's the second carbon. Remember, these things are real compounds. They exist in real life. So if I hold this up like this, okay, and that's carbon 1, carbon 2, carbon 3, and I just flip it, it's literally the same thing. It doesn't matter how you number it. 1, 2, 3, 1, 2, 3, it's the same thing. So when you attach carbons to a chain, a lot of times you can count from one side or the other, it doesn't matter. But that 2 tells us where to put that methyl group. Now, take what we just learned and apply it to this. Here's how we do it. When you're given the structure and you want to get the name from it,
Please excuse these two athletic announcements. The first announcement is for track. There is no varsity track practice today for all athletes except the distance runners. Distance runners are to report to track as usual. There is a mandatory varsity track practice tomorrow for all athletes. The second announcement is varsity boys. The game is canceled for today.
all right, so back to this. Back to this. When you want to get the name from the structure, stay with me. Pay attention, best you can. Here's what you do. You count the longest chain of connected carbons. What does that mean? 1, 2, 3, 1, 2, 3, 1, 2, 3. No matter how I count that, 3 connected carbons is my longest chain. So I'm going to keep it here. 1, 2, 3. Put a box around it. Any carbon outside of the box, you circle it. Now, we name inside the box first. So what do we call something with 3 carbons and single bonds? Propane. Good job. So propane. Write that down. You can put it underneath it. It doesn't matter where you put it. Just near there, because this is the name of it. What's this thing called? The CH3. It's a methyl. It's the same thing. And it is a 2-methyl. Good job. It's 2-methyl propane. So I drew some very similar. The difference is the main chain has 3 here. The main chain here has 4. So when you're going from the name to the structure, you draw backwards. And when you go from the structure to the name, you name it backwards. You do the main chain first, then you look at the substituent, and then you put what number carbon it's on. Alright? So those are 2 practice. Let's try a couple more. But first, I'll stop for a second. Questions? Sure. Any questions about this? Yes?
Do the numbering have to be exactly next to each other, or can you do like 1, 2, 3, 4?
Have to be in order. Sequential. Next to each other. I'm surprised no one asked me this question.
So,
Do you have
you can count from both sides, right?
You can count from both sides, but I'm gonna clarify something. Hold on. You could never call this 3-methylbutane.
Yeah, it's like a 4.
You can't go 1, 2, 3. The rule is you go for the lowest number. Go for the lowest number. So, that you possibly can have. So if I draw this structure on the board and I say, what's the name? It has to be 2-methylbutane. You can't number it from left to right. You can only choose the side when you are drawing. If it's already drawn, you have to count from the side that puts this on the lowest number carbon. Okay? So it gets a little confusing, but we're going to learn it in steps. Oh, sorry, Carly, go ahead.
Do you have to like remember what like the methyl is, like CH3?
You need to know a CH3 is a methyl. Yep.
Okay.
Yep. Yes.
You said that you always go from like the longest side.
You always find the longest chain of connected carbons. That's your main parent chain, it's called.
Alright, so when you were counting them, you kind of went from the bottom C.
Yeah, so if I give you this structure right here, I could, if I want, make that my longest chain.
I don't like that.
Neither do I. That's why I kept it straight.
Alright, so what happens if we did do that though?
It's the same thing. 2-methyl propane.
So
This is propane. 1, 2, 3 carbons. 3 carbons, single bond. That's propane. This is a methyl on the second one. So it's still 2-methyl. It's the same name.
But how do you know it goes on the left side? Why doesn't it go on the top of the C? Or could it?
On the top of the C? This?
Like, nope. Keep going up.
This?
Up on the other dash. Up.
This?
Yes.
There's an H there. There's an H there. If there's a C, you'll see it. If it's not...
C. Sorry.
Hey, yeah.
Okay.
Okay.
Can you always go straight across the top no matter what?
Pretty much, the Regis isn't going to try and mess with you. I do on homeworks, I mess with you, but the Regis doesn't. Alright, let's try another one.
Making it so you have to make it like a L shape. You do that on the homework.
Uh-oh.
Did I just?
It's still
Shh. Write this down. Just write it down. Because we're going to do this together, then I'm going to give you 2 to do on your own. Should have time to get those done, and then that'll be it. We'll do this together. This is one I have not taught you yet.
You can do it on our own first.
You can, but I have not taught it, and unless you are just magically know organic chem, you'll
But
never
now
get
I
it.
really want delicious.
Go ahead.
Well, yeah,
Or
we're just trying to
magically
figure out what it
delicious,
is.
I guess.
I bet.
That would only work if I was a Cyclops. But,
So, you just gotta figure out what that is.
yeah.
I'm not even gonna try.
I'll get you guys started, even though Destiny wants to go on her own. Count the longest chain of connected carbons. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 4 is it. So I put a box around that. Destiny, what's the name inside the box? Butane. Circle everything that's outside it. Well, just the carbons. Now, let me explain. Don't say anything because I don't want you confusing anybody. What is a CH3 group called? Methyl. CH3 is methyl. CH3 is methyl. We wrote it down. We just did 2 examples with it. This is the same thing. CH3 is a methyl. How many methyls do we have? 2. We have a methyl here and a methyl here. So write that down. There's a methyl. There's a methyl. Inside the box is butane. What carbon are both methyl groups on? 2 or 3? 2. So we got to count from the right. This is carbon number 2. C2. Does anyone want to take a stab at the name?
2 ethyl butane.
We don't have ethyl. We have methyl.
But if there's 2 of
Two
those...
methyl squared.
You have 2 methyls, not 1 ethyl.
Okay, then I give up.
Hold on. I'm going to make this clear. An ethyl group looks like this. That's ethyl.
Okay.
That's methyl. So we have 2 of those. We don't have that.
Okay.
We don't have that. It is confusing.
I like your ideas.
What's a prefix for 2?
Die.
Di. So we have dimethyl. Now here's the part that's going to be confusing even if I explain it. It's 2,2-dimethylbutane.
No.
Let me explain. The reason you can't just put 2-dimethylbutane is because of the stupid organic rules. Whoever made up these rules a long time ago. The rule is every single substituent needs their own number. So if they're both on the second, they both get a 2. So 2,2-dimethylbutane.
I can kind of understand that. It's like if one's like, branches off as a
Right, so if I put-
branches off as a methyl.
So if I put one over here, stay with me. If I put one here, how would the name change?
It'd be.
Oh
It'd
my
still
gosh.
be 2 dimethyl.
2, 3.
No,
It'd be
it's still
2, 3.
No, but
You can only count from one way. You can't count from both directions at the same time. So, in other words, if we're declaring this as 2, it's 1, 2, 3, we can't just switch it halfway through. So you got to pick one way and go with it. So this becomes 2,3-dimethylbutane.
So no matter what, on that it'd be 2, 3.
No matter what, either way, even if you did 1, 2, 3, it'd be
so
the same.
2, 3.
Right. That one would be the same.
That wasn't that.
You don't find this interesting at all?
it's
It's the most amazing thing I've ever seen.
It's because you don't understand.
No, I think she does. I think she does. Be nice, Ryan. All right. Now, we are basically out of time. We didn't get a chance to do any more. Now, the front is a little bit easier. The back gets kind of squirrely. So, give it a shot.
This was like, I'll be back in 10 minutes.
That will make
Mr. McCoy, I didn't know if you guys had.
You didn't.